Let's look at a system where we have a DC source connected to two wires that are opposed to each other, and we would call this a dipole. And so as the positive charges start to collect on the one plate, the positive charges are going to be moved off of the other line or wire into the battery source, and we get an electric field that starts to grow. And because there's a changing electric field, there's a magnetic field that's growing. But at a certain point, this process stops and the magnetic field goes away, and all you're going to have is an electric field. So here we have charges start to flow, and then we have the creation of a changing electric field. And this induces a magnetic field. I should say a changing magnetic field. But once the charges have moved with the source, or once this capacitor, made up of just two wires, is charged, only the electric field remains. And so realistically, this isn't a very useful system for us. But if we were to take and put an AC source onto this dipole, well, in the first part, it's going to act just like the DC. There's going to be positive charges that go to the one wire. Positive charges come out of the other wire, so it becomes negative on the bottom. And you get the same situation that we had with the DC source, but now in this next picture, when it flips, now we have charges moving in the opposite directions. And there's a folding of the magnetic field around, and because there's this folding magnetic field causes the electric field to fold, or to start going in a curve. And this process continues to happen where you have these packets of electromagnetic energy that are self-sustaining. There's no enclosed charges or magnetic poles necessary. This process continually works on itself, and it expands out from It's this location of this dipole in these packets. We call these packets photons. So this is where we find use. We'll find out, we'll talk more about how we use this for radio and television. But it also has other uses and implications for us.